So today we're focusing on trig functions, specifically the sine graph. This is the standard form of the sine graph. Y is equal to a sine b x plus or minus p close bracket plus or minus q. So we're going to look at how a, b, p, and q affect the sine graph individually. So if we have y is equal to a sine x, how does that a affect the graph? Like the for example the period. Things that are affected are the period, amplitude. By amplitude, what do we mean? We mean that it's range. We mean like it's range. It's range from the baseline. The baseline is always equal to 0. So the baseline is always equal to 0. So the things that are affected by A, B, Q, and P and Q are the period, amplitude, what else? The horizontal and vertical shifts. And the what is this? Is the horizontal and vertical? Yes, done. That's all. So it's 4 things. So we have how many variables? A, B, C, and Q. I mean A, B, P, and Q. So we have 4 variables. This is the first one, the second one, the third one, the fourth one. So all these things are affected by these ones. So we will look at how each affects, which one affects what. So first of all, we're starting with A. As I said, A is affected by, A affects the amplitude, like the range from the baseline. So we all know the standard graph of sine is sine y, and it's drawn like this. So sine always starts on then it goes, yes, passing through the 0 and back to 360. So 360 here, and it's also 360 here, minus 360 degrees. So sine, the normal sine graph starts at 0. At 0, x is always equal to 0 when it starts. So and then it goes passing through 0. So and here, since it's 1, we all know that this is 1 here. So the amplitude that it reaches, and here on top and on the bottom, is always -1, and here on top is 1. So that's the only amplitude that it touches. But now let's say we have sine 2, y is equal to sine 2. So our new graph will be like this. Still, it's starting at 0, but now it goes to 2, then comes back to 2, and so on. You see, the one that was here, like these ones here, -1 and 1 here, are now affected because now the graph touches at 2, and it also touches here and so on 2. So that's how A affects the graph. It affects A affects amplitude. I don't know if it's amplitude or amplitude, but I know it's the range. I'll research that. So it affects the range. Done with A. So then B, we know the normal graph is always sine x, right? I drew it, this is the one. But now y is equal to sine bx. What does it mean for our graph? b affects B affects the period of the graph. You will have questions asking you like, what is the period of the graph, right? Like, when does it start repeating itself? That's what it means. Like when we say period, we are asking OT, when does it start repeating itself? Like, what is the period of the graph? So it will be something like this. The period, we all know that the period is equal to 360 divided by, they usually use K, but in our case I used B, so it has to be 360 divided by B. So whatever number B is, that's how the period is affected. For example, we have a graph of sine 2x. Then they ask you, what is the period of this? The period of this is gonna be equal to 360 divided by 2. Done. 180. The period now changes to 180. So what does that mean? It means that the graph will start repeating itself each and every time after 360 degrees. So I mean after 180 degrees. So on the first graph, now let's look at this one. You can also look at this one of that is affected by A. You will notice that from minus 360, the graph is going, and then from here it stops. Are you aware this is the same point as that one? So it's repeating itself again now, and then it stops at 360. Then from 360 it's gonna go on again, maybe like this, and then it's gonna stop. What is 360 plus 360? You get 720. Yes, it's 727. Let me check. 360 plus 360. Yes, 720. So that's how it's affected. Now we are looking at 180. So what do I mean when I say it will repeat itself after 180 degrees? So this is what will happen. This is how the new graph will look like. Obviously it has to start here, then it goes, and then it goes at 180, negative 180. This is negative 360. At negative 180, it's when it's gonna start again doing the cycle. Then also here at 0, it's gonna repeat again. Sorry for the I can't even see. Yeah, there's it. And then also here it's gonna start repeating itself again. Then at 180 again, then it goes again, and then it ends at 360. So that's how the period is affected. Then you notice that the graph shrinks. Now it becomes smaller and smaller. Like it's more like it's affected in a shrinking manner. Like it's shrinking. For compared to this one is more spread out. This one is more shrinked. Or this one is more shrinked. So that's how the period is affected. So done. So now we're looking at what is horizontal? So we're looking at horizontal shifts. Horizontal. So a horizontal shift is sideways. Just remember that, sideways. So it has to be sideways. And which value And which line is sideways? It's x. It's always x. Line x is sideways, and then line y is vertical. Yes, that's how it is. So this means we are looking at y is equal to sine x plus p. Okay, so plus or minus p affects what? The like the horizontal shifts. Horizontal shifts. But now we're gonna, since it's plus or minus, that means I'm expecting two things to happen. I'm expecting a right shift and a left shift, and it will all depend on plus or minus. So which one is it? Plus p, how does it affect the graph? So a positive p means that the graph um, shifts to the left. So what do I mean when I say it shifts to the left? So you will notice that the normal graph of sine is like this, right? We discussed this earlier. 360, right? So now what needs to happen is that it must shift a certain degree. This has to be in degree form because can't be one. This is an angle, so it has to be also affected by an angle. That's why you will find questions like sine x plus 45 degrees, right? So, and they will give you like the step that they want the graph to be drawn. Like they'll give you like your step must be like, for example, 45 degrees. So when your step is 45 degrees, how do they mean when it's like that? So basically what they mean is that now the graph shifts to the left, right? Since this is the normal graph, let me redraw it. This is like the normal one, right? This is 180, this is 0, negative 180, this is negative 360, right? 0 degrees, yeah, so it's in degrees, right? Then here it's 1, here the bottom is minus 1, right? So that's how it is, right? So now the shift that they're talking about is that when this graph moves, it's no longer in its same position. It has now moved 45 degrees. 45 degrees. This pen. 45 degrees to the left, right? So now we're gonna count. We're gonna count going to the left. So we have negative 360, right? If we want to go to the left, we're gonna minus 45 degrees, right? Then we have 405. 405, it's not like, it's not within our range. Maybe they say your range is 360, negative 360 and 360 degrees, and I will strictly recommend that, right? So now we go to 180, right? We move negative 180, we move it to so we're gonna have 225. So now what used to be a 0 is now moved to this part of the 0. The 0 shifted to here, right, with 45 degrees, right? Let me find out what is 1 here under 360. So 270 270 was 1 here, So this was 270. Now 270 is also have to shift to, I'm saying minus 45. I'm not saying plus, because now a shift, it means we're shifting to this side. We'll have to use the negative, the negative one to go to this side. So now the 270 is now 315. 315. So 225 is now 3. I mean 270 is now 3. So it's gonna be there. So 315, something like that. So what I basically mean is that, yeah, let me also find out here. I think it's 90. So 90 used to be 1. So it used to be 1. Now let's find out what it is. Now 135, negative 135 is now 1. So it has shifted how many degrees? 45 degrees to the left, right? So that's how it is. And then the 0 that used to be 0, it has now also shifted to 45. So here it's gonna be obviously 0 minus 45. Obviously we're gonna land at minus 45, right? So 45, right? Then what used to be 1 was 90 degrees. So when I say 90 degrees minus 45, we get to the 45. So we shift to 45. So now 45 is 1. It's 1 over there, right? So this graph will look something like this. Something like that. So now if I were to neatly throw it, it will look something like this. This, we call it the y is equal to sine x plus 45 degrees. So this is y, this is x, right? So it looks something like this now. 315, negative 315, negative 225. My scale is too small. Let me redraw it again. Negative 315. This is 0. This is 45. This is 135. Negative, right? This is 225. Negative 225. So it's in degrees also. So redrawing that graph, it's no longer starting at the baseline now, because it has shifted. The baseline is shifted to what? To 405. Remember we found 405 there. So the baseline is shifted to 405. Now we're gonna focus on a range of 360 and 360, negative 360 and 360. So 405 doesn't fall within that range, so we're now focusing only on this part. So it's going to be something like starting here, we know this is 1, this is negative 1. Forget about my scale, just to focus on what is going on. And then it goes, I'm sorry, it's like this. Then passing at 0, which is 45. Then it goes to pass on 1. It's not precisely 1. It's under 1. It's not precisely 1. It's 0.7071. So 1 is somewhere here. So it's gonna pass there. Then when it at 45, that's when it touches 1. At 45. Then it repeat. Then it goes down to 0. 0 now is what? 0 now, it's 3, 1, 3, 1, 3, 5. Then 2, 2, 5 now. it's no longer 0 like on the negative side. It's now 1, and then it ends at what, 315, which is 0. Yes, it ends there, right? So it has shifted. So now, to check if we're correct about our shift, from 360, if we minus 45, we will get what? You will get 315, right? So here at 360, our x was equal to 0, right? At 360. Now at 315, our x has to be 0. So if you check here, our x is actually 0 because it's touching it x, right? So we have, yes, the shift was a fantastic shift. So a positive, it means the graph is shifting to the left. So now a negative, where would that shift to? Obviously, if the positive shifts to the left, and then the negative has to shifts to the right. So if it shifts to the right, so this is what we mean when we say it shifts to the right. I'm gonna use a red pen for this one, the right shift. So just know to, okay, sine x minus 45. Now it's no longer a plus 45, now it's a minus 45. So let's look at it. Still the same, the steps applies, the 360 still applies. This is like, what I'm doing here is like drawing a graph without using a calculator, you see. But then I'm referring to the calculator myself so that I can give you accurate stuff, you see. But then yes, so let's move on. So now we know the normal graph, of sine. It's starting at 360, goes, it ends at 360, right? Negative 360 here, right? So that's how it's of in the normal graph is. Guys, if you can be able to know the normal graph, then you're sorted, because from the normal graph, that's where you can do all your shifts, play around with the graph, find out everything that they want you to find. So now they want us, I'm gonna use a black pen to indicate the, because here for this one I use the red pen to indicate the shifts. So now let's find out with the black pen, how will we handle this shift. So the graph will be going to this side now, because from here we found out that the graph went that side. This point, as you can see, this point went to that side. Also this point went to that side, this point went to that side. Even 360 went to 315, which is lower than 360. So everything was going to the left, right? On the previous one, everything was going to the left. So now we're going to the right now. So at 360, we're gonna move 360, the point of 0, 45 degrees to that side, right? So what I basically mean is that it's gonna be something like this: negative 360 plus, now we're using plus now, plus 45 degrees. So 315, I mean, yes, 315 is somewhere here, because this is 270. So 315, negative 315 is now our new 0. Now 315 is our new 0. It's no longer 360. So from there, this is also, we remember from the previous one, we said this is 180. So negative 180 plus 45. Now 315 is our new 0. I mean, is our new 0 again. Yes, I'm correct. So 180 is our new 0 again. I mean, 135 135 is our new zero. Sorry about that. 135 is our new zero. But then we need to find out what is our 1. Our 1 was 270. So negative 270 plus 45. So it's gonna be 225. Negative 225, right? As you can see there, negative 245. So from 270, it shifted to 225, which is somewhere here. And then this was 90, negative 90, I mean, negative 90 plus 45. Obviously, it will shift to negative 45. Then our 0, when we add 45, obviously, it's going to be 45. So 45 is the new 0. Then 90 here will shift to 315. 315 will be, sorry about that, the numbers, 135. 135. So that's our 135 right there. So it has shifted 45 degrees. So now let's draw the graph. We said this is our new 0. So from our new 0, we have to go to a 1. There's our new 1. This was the old one. There's our new 1. Then from the 1, we need to go to the 0. There's a new 0. We said it's gonna be 135. Now I'm confused. Yes, I'm confusing myself with this scale. The scale is too small. So this was 180, right? So our shift was here to 135, negative 135. So it's a negative 135 is our new 0 again, replacing 180. And then 45 now, negative 45 now, it becomes the negative 1. And then it goes on to pass at 0 there. Yes, 0 is our 45. Then it moves on to there. So we have a rough scale or sketch of it. So let's draw the final product of it. Sorry about drawing so small things. So now let's draw the final one, the final one. So it's called y is equal to sine x minus 45 degrees sine, right? That's the graph we're drawing. So it's had, we start by 0, minus 45. That's the step that they gave you. Negative 315. Negative 135. I don't know why I keep confusing these numbers. Negative 225. And then negative 315. Yes, that's 315, not this one. 315. So as we said, it shifted to the right. So now it's gonna be going up, touching 1. There's 1 there. There's negative 1 there. So yes, touching 1, coming back down to 0, then touching negative 1 somewhere there. Can't force it. 45. We know it's going to 45. 13, 5, 225, and 316. Yes, so it's gonna be going up, going down, then crossing there, then coming back up and crossing at 215 at 0. Then it goes beyond our limitation, which is 360. So we can't we can't go to 405. 405 is the number after 350. So if 360 plus 45, you find out that it's 405, and 405 falls outside the range of this one. So yes, that's how the graph that has shifted will look like. It shifted to the right, it shifted to the right, it shifted to the right. So guys, as you practice, you will find out these things are easy. Now let's look at the vertical shift, the last one. Vertical shift, it's the last one in the easy one. So the vertical shift is that p plus or minus p. It affects the graph by moving it upwards and downwards, ups and downs. It's fine. Okay, so for up, obviously it's gonna be plus. Unlike the horizontal shift, where you find out that the positive means left, the negative means right. This one is just straightforward. If we add p to a graph, then the graph has to move p units up. So what I basically mean is that, taken from the original sine graph, this is the original sine graph, right? So it goes, crosses there, crossing there, and it stops there. So we all know that the highest amplitude is always what, 1 and 1, right? So now if they were to say okay, let me just conclude this, goes up. So now if they were to say sine x plus 2, right, plus 2, so what they mean is that from this negative 1 you must add 2 units, right? So negative 1 plus 2, that's around positive 1, right? So it will shift 1, 2, positive 1, right? So it means that these 2 points are now shifted upwards, right? So this is how the new graph will look like. Okay, even this one will have to shift up from 0 to 2, right? Also this one from 1 to 3. Then also this one from 1 to 3. So I have to extend this line. This is 1, 2, and 3, right? This is negative 1, negative 2. So negative 2, negative 1, 0, 1, 2, 3, right? Still, the degrees are still kept in that way. But then now the graph will be flying some way. So from this 360 here, it shifted 2 units. So it's still at 360, right? It's still there at 360. But now it doesn't start at 0. It starts at 2. Yes, that's 2. And then 270 now. 270. This is 270. 270 now is at 3. 3, right? And then 180, which was resting upon 0, is now also at 2. Are you seeing these plots? That they're forming a curve already. And then 180, I mean this 90 here, 90, it was at minus 1, so it shifted 2 units, which it will land it at 1 there. there's one, there's one, and then 0 obviously shifted to 2. So roughly the graph will look something like this. Roughly it will be flying like this, then going back up again, coming back down again to 1, and then completing its cycle at 2, right here. You see, it's no longer touching the x-axis, so this graph does not touch the x-axis. Bear that in mind. So if it's like this, the graph does not touch the x-axis, so it shifted from each and every resting point. It shifted 2 units up. So since y was equal to 0 here, it has to shift plus 2 units up. So the vice versa is true, which is minus q goes down, right? So if it goes down, this is what we basically mean. It goes down by that. Now the new graph is going to be y is equal to sine x minus 2. So what we mean is that the original graph, which is sine, the original graph of sine, now okay, taken from there. Now let's shift this one to form this one, right? So this is what we will do. 360, right? Let me just measure out everything carefully. 90, 180, 270, 360. 90, 180, 270, 360. So this is negative 360, right? Negative 360. This is positive 360. Positive 360, right? So what I mean when I say it goes down, it shifts downwards. So from 360, the graph now no longer starts at 360. It's gonna start where? Negative 2. This is negative 1, negative 2. I need to have negative 3. Negative 3, negative 2, negative 1. 1, 2. 1, 2, right? So this is what I mean. So 0, it was 0, right? Now it shifted to 2. It's still 0. I mean, it's still 360. That's what I mean. It's still 360. Now at 270, it was what? At 270, it was 1, right? 1 minus 2, it gives us negative 1, right? There's our negative 1 there. 270, negative 1. Then at 180, it was 0. So it has to go down. 0 minus 2, which is minus 2, leaves us there. Then also at 90, it was negative 1. So negative 1 has to go further. Negative 1 minus 2 is negative 3. So it's here. 90 is at 3. Therefore, right? Then 0, negative 2. And then what? 90, it was 1. Now it has shifted to negative 1, because 1 minus 2 is negative 1, right? Then 180, it's back at minus 2. 270, negative 3. 360, negative 2. So it's looking like this. roughly like this. Yes, as you can also see, it's flying, but now it's no longer at the top, it's at the bottom. So that's how you notice these things. This one is at the bottom, and also this one does not touch the